So in this video, we're going to talk about the translations of sine and cosine, or the shifting of sine and cosine graphs, and specifically horizontal translations. Well, I want you to kind of think back to perhaps college algebra or somewhere back, maybe algebra 2, when you learned about the translation of a function. These values might look familiar to you, or these letters. Remember that if we have some function where this is my function, in this case I'm looking at an x squared function or a quadratic function, and if I have a minus h on the inside here, I had a k on the outside, I had this a in the front and a negative sign. Well, we learned, when you have learned previously, that when we have these things going on with our function, then it tells us certain ideas about what our graph is doing. For example, anytime that there's a negative sign in front of this value of a, then we're talking about it reflecting or flipping across the y-axis. In our translations, we also learned that this a for us in this function was to shrink it or stretch it. We also had a number inside of the parentheses here. This number stood for a horizontal shift. In other words, it was going to move left or right, and it was never the same sign as what it appears. So if we were looking at this function right here, then this would have a shift to the right. Okay, it would have a shift to the right, whatever that value was. The last thing that we might remember is that if I'm adding a number to my function, then I had a vertical shift. So that's what it would look like on functions in general, but let's look at this specifically relating to trig functions. Here I'm showing you the sine function, and it's going to be the same. We have all of these values that would be the same for us if we were talking about any of the other 5 functions, where we know that a for us in this case stands for the amplitude. Remember, that's the value along the y-axis. That would be also like our range. And then if we have a negative amplitude, or this negative sign in front of my a, then we are going to again just reflect across the x-axis. We also have here a shift, okay, where this is inside of the parentheses with the variable x. Okay, so if I have a horizontal, we call this a horizontal shift. In trig, or in trig, we call these phase shifts. So a phase shift is technically a horizontal shift left or right. We have the period of the function. Remember, this tells us how many complete pictures we have. Then we have, last but not least, the vertical shift. So these have different values, different letters, as opposed to what we just looked up above, but it's the same concept as what you know originally from when you translated functions. So let's see, with this first example, what happens when I take a graph and I shift it horizontally, or in other words, I do a phase shift. So this is the first example. Y is equal to the sine of x minus pi over 3. And I want to graph this for one period. So the amplitude of this function is 1. What else do I know? The second thing I know is that b is 1, and therefore the period, which was 2 pi over b, is really just 2 pi, giving me an interval between 0 and 2 pi. Now I'm going to take this interval and I'm going to break it up first, right away. We know that this breaks up into 0 and 2 pi. I know halfway in between 0 and 2 is going to be pi. Halfway in between 0 and pi is pi over 2. And I can go back and ask myself, well, how did I go from 0 to pi over 2? It's adding 1/2. It's incrementing by 1/2. So if I add 1/2 here and 1/2 here, then I'm going to add 1/2 to this, and I get 3 pi over 2. The next thing we need to recognize is we have a phase shift. That's what this value is inside of here. That tells me that I'm going to be moving in the direction opposite of this symbol. So I'm going to be, instead of subtracting pi over 3, I'm going to be adding pi over 3 to each of these interval values I just made up. So we're going to come in and we're going to say plus pi over 3 to all 5 numbers. We're going to add those straight down, and we can see that when we add these up, we end up with pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. So if I know what the amplitude is, I know what the intervals are, and I don't have anything else to really deal with. The period was still this 2 pi. We're going to come down here and we're going to draw the function. So rather quickly, since I know the amplitude was 1, I just come in here and put negative and positive 1. I mark off the x-axis with these values up here. I know you're doing this yourself on your paper as well. And now we're going to graph the function. We know sine always starts on the x-axis. Then it moves high, comes back to the x-axis, moves low, comes back to the x-axis, and we quickly drew the sine function using translations. Well, let's practice that again. This time we're going to graph 3 cosine of x plus pi over 4, only I'm not going to do both methods. From now on, I'm only going to do the translation method. So I'm going to come in and I'm going to identify the parts of this that tell me how to translate the function. The first thing I want to look at is the amplitude. The amplitude is that coefficient next to my trig function, so I know that the amplitude would be 3. The second thing I want to look at is the period. The period of this function would still be 2 pi because I know cosine is 2 pi and I know b is 1 in this case. So if I know that the period is 2 pi, then I'm looking at an interval between 0 and 2 pi. I also know that I have a phase shift because I have this fraction being added, or I have a number being added inside of the parentheses. So I have a phase shift, which is going to do the opposite. So in other words, it's going to subtract pi over 4. So now that I know all of that information, I'm going to come over here and I'm going to write out my interval based on my period here. So I have 0, 2 pi. Halfway between that is pi, pi over 2, 3 pi over 2. So that's the original value. But I'm going to shift everything to the left by negative pi over 4. So I'm going to subtract negative pi over 4 to each of these values. So if I come through and start, I know the first value right here is going to be negative pi over 4. And I'm going to go through and I'm going to calculate the rest of these values. Okay, so I went through and I did the subtracting pi over 4 from each of these values, and I came up with a new set of x-intercepts occurring at these 5 spots right here. So if I know what the x-intercepts are, I know what the amplitude is, then I'm ready to graph it. So let's come down here. We're going to graph this function. We know we start over here at negative pi over 4. We'll just kind of break this up like this. Halfway in between, half and half. So I know that the left-hand side over here is going to be negative pi over 4. 5 pi over 4, and finally 7 pi over 4. I know I have an amplitude of 3, and I have So I need a 3 and a negative 3. And that's all I really need to know, and I'm ready to graph it, except the fact I need to remember that it's cosine. Cosine is always going to start at a maximum, so I have a maximum point over here. Almost missed that. I have a maximum point here. I'm going to cross at pi over 4. I have a minimum down here. I cross at 5 pi over 4, and I have a maximum over here at 7 pi over 4. So when I connect the curve, you can see I have a cosine function. So that doesn't take very long at all when we identify the individual parts and we break it down by translation.